All right, we're going to work on what's called a proof, some formal proofs for geometry. When we do this, we have two columns, one with statements and one with my reasons. We always start with this note at the bottom. We always start with the given. Stated first. Stated first every single time. So my given is always composed of a statement from a problem or an item specifically called out in the diagram. We're going to use a lot of things from my diagram. So I want to start off with things that I know that are given to me. And that is specifically shown. I have angle A and angle D being congruent to each other. So that is a given statement. I also have this side is congruent to this side. Side AB is congruent to side DE. That was also given. And the third thing that's shown in the diagram is that B and E are congruent to each other. So angle B is congruent to angle E. That is given. It was shown in the diagram. And so my goal is to prove these two triangles are congruent. That's my goal. So my last statement down here is always to end with whatever you're trying to prove. And so I have an angle, a side, and an angle. So I know that those two triangles are congruent by my angle, side, angle theorem. And I can write a little congruency statement. Triangle A, B, C is congruent to triangle, and let's make sure we match up our letters. A is with D, B is with E, and C is with F. And that is it. That is my proof. My goal was to prove my two triangles congruent, and that's what I ended with. That's what I did. I proved them using this theorem. I have an angle, a side, and an angle. And so I was able to use angle, side, angle theorem to prove those triangles are congruent. So start with our given, end with what we're trying to prove. Given to prove. Let's try another one. I have a couple things marked here. And let's start with our givens, right? Given statement starts first. And so I know that side RS is congruent to side ST. RS is congruent to TS. That was given. The other sides marked given are RU and TU. So given RU is congruent to TU. Now I don't have any more givens. Those are the only two congruent pieces that were shown in my diagram. The third piece of information, though, that I do know is that SU, this side here, is shared. This could be considered my third side, my third piece that I know is congruent to each other. I know that SU is congruent to SU. My reason for this is something called the reflexive property. Now the full definition of the reflexive property: a side or angle is congruent to itself. So in this case, SU is congruent to SU. And so anytime I have a side or an angle shared, right? This is a shared side. Anytime I have a shared side, I can use that as one of my pieces of information to prove my two triangles are congruent. So I have given, given, and then I have this reflexive property. This is a side, and a side. So I know these two triangles are congruent to each other by SSS theorem. And so I can say triangle SRU is congruent to triangle T view. And then I am done. Once I prove that the two triangles are congruent, I am done. I start with my givens and with what I'm trying to prove. Let's do my next one. Let's start with, I got two given statements here. There's two pieces marked out. I know side AC is congruent to side DC. I know side BC is congruent to side CE. And now I need one other piece of information. Well, I have this little vocab down here, vertical angles. Let's write down what vertical angles look like. Vertical angles are essentially angles that are across from each other and share a vertex. And we know when that happens, they are congruent. If you want a nice little picture, it's when I got two lines intersecting. This angle and this angle are congruent to each other. They are equal to each other. They are vertical angles. And so if you look at the top of your paper, we have that same crisscross action happening. This angle here is congruent to this angle here. So let's write that down. Angle, this is BCA, is congruent to angle ECD. And that's because they are vertical angles. Property of vertical. They are vertical angles, and so I can write down a statement that they are congruent to each other. I know that about vertical angles. That's the definition of being vertical. Now the rest of this, it's asking us to prove that angle B is congruent to angle E. I want to know if this angle is congruent to this angle. That's what I'm trying to prove. Well, I don't know that unless I know that my triangles are congruent. So that's going to be my next step, is I know that these two triangles are congruent because of side, angle, side. Side, angle, side. So I'm going to write that down. Side, angle, side theorem proves that my triangle ABC is congruent to triangle DEF. And when I know that these two triangles are congruent, then yes, B and E are also congruent because I have what's called CP, CTC. That's what we practiced last. And it means corresponding parts of congruent triangles are congruent. So I can say that yes, angle B is congruent to angle E because of this statement, CP, corresponding parts of congruent triangles are congruent. After I prove that my triangles are congruent, then I can say that my parts are congruent. Now let's try this last one. In the diagram, we are given that G and K are congruent to each other. That's given. We're also given that F and J are congruent to each other. And then we're given this statement right here. H is the midpoint of GK. So I'm going to write that down. And that is my third given piece of information. Now midpoint is a nice vocab word. So let's write down what midpoint means. Midpoint is essentially splitting my segment into two equal parts. So I would write that down, a point that divides a segment into two equal parts. So essentially, this point H is splitting this whole line into two equal parts. I know that this side is going to equal to that side because H is the midpoint of that whole space. So I know GH is congruent to KH because H is a midpoint of GK. That's how that works. So now I have two angles and a side, and so I can state that these two triangles are congruent by angle-side angle theorem. And lastly, we are being asked to prove that these two sides are congruent to each other. So once I know that my two triangles are congruent, I can say that yes, this side, FH, is congruent to this side, JH, because they are corresponding parts, C, P, C, T, C. FH is congruent to JH because they are corresponding parts of congruent triangles. And that is it.